Hello friends, our today's topic is interfacing of LCD with PIC16F877 a microcontroller. As in earlier topic we discussed regarding interfacing of switch and LED with the PIC microcontroller. So these are the some reviews, how to decide the port as an input port, as output port, with the help of data direction register and with the help of port for actual data accessing. So now we discuss regarding LCD. So before actual interfacing starts, here some points related to LCD need to be analyzed. That is, as a name itself indicates that 16 by 2 LCD, if we consider the basic model of LCD is 16 by 2 and it is mostly used for most of the applications. So here 2 means 2 rows are there and 16, that is the number of characters available in each row. So first row it includes 16 characters and for second row again it includes 16 characters in the sense of it will indicate some numbers, characters, that is first uppercase, lowercase, as well as space is also considered as a character between the two words or two values. So total 16 characters are available per line, so two lines are there. So LCD is having some different versions or modules are like 16, 20 by 2, 20 by 4, 40 by 2, 40 by 4, 80 by 2, 80 by 4, like that. So as per user requirement, we select the LCD for the interfacing with the PIC microcontroller. So here again the matrix size is nothing but the character size, width and height. It should be mostly preferred as a 5 by 7 pixel matrix, and which is selected with the help of a LCD command 38 hex value 38. By sending this command we will select 5 by 7 pixel matrix. And while using LCD, here two modes are specified in LCD. First mode is command mode and second one is data mode. So LCD operation is splitted or divided into two parts. First and most important is command, and after specifying commands we are able to send the data on LCD. So LCD mostly receives the contents or data with the help of ASCII values or ASCII characters. Okay, so we'll discuss some basic interfacing diagram of LCD 16 by 2 with microcontroller. Here we use microcontroller is PIC16F877A, and for this 16 by 2 LCD total 16 pins are there. Out of that, first pin is connected to ground, second pin is connected to VCC, third pin is used along with the potentiometer or a variable register, or simply we say that the pot, trimmer, etc. for adjusting the contrast of an LCD characters. Okay, so characters which are to be displayed on LCD actual data, its contrast or brightness is adjusted with the help of this pin number 3, and from pin number 7 to pin number 14 actual data lines are used, that is D0 to D7 data lines are used, and here we connect the output pins from the microcontrollers for accessing the actual data. The remaining three most important lines are RS, RW and enable. RS is nothing but register select, RW read write operation, and E stands for enable, enabling the pin. Here some cases it is mentioned EN. Okay, so while as we mentioned, the LCD operation is divided or splitted into two parts, that is command mode and data mode. So for command mode we should make RS is equal to 0, and for data mode we should make RS is equal to 1. So selection of command and data mode is depend on RS pin status. And next is RW. Here RW stands for read or write, that is if we want to write the content or message on LCD, in that case RW pin remains low or it should be equal to 0. That is, here we mention connected to the ground. And if we get the content or get the status of LCD from LCD to microcontroller, in that case RW pin is equal to 1, that is connected to VCC. Generally, in most of the cases, we write the contents, that is message, on the LCD. So most of the cases we make RW is equal to 0 or simply connected to the ground. Here last pin, that is control pin, that is E or EN, enabling the LCD with the microcontroller. So by making a high to low pulse for a some time interval, it should allow to write or get the access of LCD with the microcontroller. So EN or E pin is used for allowing or enabling the LCD to access either command mode, either data mode. So for each instruction, it should be high for a particular time interval, and again it should be applied as a low signal or connected to low signal. So these are these three most important control signals. After that, last two pins are also there here, not mentioned, that is pin number 15 and 16. Here pin number 15 is used to connect a backlight LED positive terminal, and pin number 16 is used to connect backlight LEDs negative terminal, that is ground. That is pin number 15 VCC and pin number 16 is ground. So backlight LED is nothing but the LED is used as a background, that is generally we see the yellow light or a yellow display. So here yellow indicator LED is connected in between 15 and 16. Okay, so we discuss the pin configurations as I mentioned already. Pin number 1 connected to ground, VCC, contrast adjustment, register select, enable, read write, and data lines, like that. Okay, so we move further. Here, as we discussed earlier, RS, RW, and enable pins. So here enable plays an important role. So by making enable pin high and wait for some time interval, that is adding some delay, and again it should be connected to the low, that is making it is 0. So in that case only we are able to access the LCD, that is sending the some commands or sending some data. So enable pin, that is enabling the LCD for your access. RS, as I mentioned, selection of register. Here if we make RS is equal to 0, data whatever the contents are written on LCD, it should be considered as a command, that is instructions for like clear the screens, cursor position, row position, blinking of the cursor, cursor off, cursor on, like that. And if we make RS is equal to 1, in that case all the contents are considered as a data contents which are to be displayed on LCD as per your earlier selections. And next part is RW. Here read write, that is when we read the contents from LCD, in that case only we should make RW is equal to 1. And most of the cases we are writing the contents, either commands or actual data to be displayed on LCD. So generally we make RW pin is equal to low, that is connected to the ground. So these are the control signals. Here I mentioned some steps related to sending commands as well as sending data. Steps are same for the both cases, but only one change is there with respect to the RS pin status, that is initialization of LCD, that is as a command, or initially first as a command, after that make RS is equal to 0 for command mode, RW is equal to 0 for writing the or giving the commands to the LCD, and after that simply make a enable pin high for some time delay, and again it should be connected to the or make it to low. So only one change related to the sending data is by making RS is equal to 1, that is change in status, that is RS is equal to 1, and the rest of the process remains same for sending data also. By only making this change, the whatever the contents or characters are sending from controller to LCD are considered as a actual message to be displayed on LCD. So after that we discuss here the code, and in this code here some initial settings by with the help of here we are using MPLAB, and after initial settings like source file adding, header file adding, and then we start as a C program. So here pic.h, or you simply mention the PIC16F877A.h for accessing the SFRs and some registers of PIC microcontroller. Next part is stc.h is used for high-tech C compiler. Here we are using high-tech C compiler, so we are using here htc.h. After that we have to select the uh, controller's port as output port for accessing data of LCD pins, that is D0 to D7. Here we require 8 data lines. So we select one port as output port and connect it to the data lines. In this code we are using port D as our output port for accessing the data, and again 3 more lines are required or pins are required, that is we are selecting here RC0, RC1 and RC2 as a control lines for RS, RW and enable pin. So here we require 2 ports, that is one port completely, and from next port we require 3 pins RS, RW and enable. So here we defining that individual pins, hash define RS RC0, that is RC0 is nothing but RS, RC1 is nothing but RW, and RC2 is nothing but enable. So as we mentioned in the steps, we required to make enable pin high for some interval, and again it should be low. So in that case we assign one delay function regarding the enable pin. So initially we make en is equal to 1, adding a delay with the help of for loop, and again it should be making en is equal to 0. So this delay function is applied for each and every command or data mode. So we move further for main function. Here in main we need to require to specify the given ports as a output ports. Here no need to specify some input port or input connections. In next part, that is for interfacing of LCD along with the keypad, or LCD along with keypad with 7 segment. In that case input as well as output both conditions are required. Here we are only interfacing LCD as an display device or output device, so no need to specify input port, only output port is sufficient. So to get the message continuously, we are writing the next part is in while loop for continuous. So as we mentioned, initially we need to give the commands, and after commands we are sending the data. So for command mode we should make rs is equal to 0 and rw is always 0 for writing the contents either command or data on the LCD. So here we gives first command, that is 0x38, that is which will indicate that the matrix or character size is 5 by 7. Again after giving command we should make enable pin high and again enable pin low. So simply make mention delay for one time repetition or completion loop, delay loop one time. After that again 0c, that is 0x0c for display and cursor position. Again delay function is added, that is making the enable pin 1 and again low to the 0. And after that here I mentioned port T is equal to 0x80. 80 is nothing but your row position, that is 80 is your first row 0th position, that is first position, starts from 80 to 16 characters. If we want to use the next row, that is second row, in that case use port D is equal to 0x C0. Again if we want to give some space between the message to be displayed, so instead of 80 you simply mention suppose 8484 So in that case, here we use 8485 or C4, C5, C6 as per space requirement. So here initial cursor position is selected to set the data or send the data. After initial setting, we are using actual command, data mode. So for that purpose, we should make rs is equal to 1. So after making rs is equal to 1, we transmit actual ASCII characters or ASCII values with single quotation or double quotation. So port D is equal to quotation T. Here I want to transmit the message TEENTC. So I mention first character T, again delay, second character delay, third character delay. If you want to give some space in between that, so mention simply in single quotation space, that is one space bar is there used. And so if you want to use two spaces, then use space bar two times. So after that you will get the spaces as per your requirement. So here space is also considered as a characters. So this is the basic uh, interfacing of LCD with PIC16F877A microcontroller. Thank you for listening and watching. So now for next lecture we will discuss regarding how to interface the 7 segment display with PIC16F microcontroller. Thank you.